Alright, this lesson we're looking at piecewise linear graphs. So piecewise linear graphs just means that there's multiple pieces of linear graphs, linear equations in one graph. And to show that where the graph is starting and ending, because piecewise graphs often have a domain. And domain just means that our x values are going to have a starting and an ending point. So we're going to have some endpoints. And sometimes the endpoints will be included as part of the graph. Sometimes they will not be included. So to show that, it will use a closed circle for including that point and open circle for excluding that point of the graph. Let's have a look at this example. As you can see, to sketch this piecewise graph, there are two parts and two equations, one making each part of the piecewise graph. If we're looking at the first one, from the value of x being from -9 over here all the way to 2, +2, this part of the graph, I don't know what it looks like right now, but it's probably looking something like that, is going to follow this linear relation. So when we graph this between these two values, that's what we want for the first half of the equation. For the second half of the graph, we want it to go from 2, so we're overlapping at 2, all the way to 7, so over here. So this part of the graph is going to follow this relationship between the x and the y. And it'll probably look something like that. So it had this piecewise linear model has a starting and ending point over here, and the second half will also have a starting and an ending point. So how do we determine where these points are and what it looks like? Because it seems like a lot of work. The best way to go about it is to use the CAS. Alright, so once you have your CAS, you'll go into graphs. And you're going to graph the first equation. So 0.5 times x plus 3. And we have a graph. But obviously, we didn't give our CAS a domain, a starting and an ending point. So it just goes on forever this way and forever this way. But we know for our one, it has to start at -9, ends at 2. So to find where these points are, you're going to menu trace and graph trace. And you're going to simply type -9 and enter. And it takes us there. So for this graph, when x is -9, y is going to be -1.5. And then we're going to find that point here on the graph. So let's do blue for this one and then maybe yellow for this one. We just pick that point, but you see this sign here, this means x includes, it's equal to -9. So we need to include this point as part of our graph. So where x is -9, y is around -1.5. So it's right there. And we should make sure it's a closed circle because it's included at this point. And we want to label it as well. All right. So this is where it's starting and it's ending at 2. And we're not including 2. As you can see, the sign doesn't include 2 because it's not equal to 2. So to find where that point is, simply type 2 and enter on the CAS. It'll give you that point, 2, 4. So we're going there. X is 2, y is 4 right here. So this point right here, and make sure we're not including it. So it's an open circle. And we label this point 2, 4. Now, this is a linear graph. We have 2 points, our starting and ending points. So all we now need to do is draw a straight line between the two. I'm going to try draw one a little bit better. Yep, good enough. So that's first half of the graph done. The second half of the graph happens from when x is 2 and we're including the 2 all the way to when x is 7. But for this part of the graph, so see I pressed the tab button to bring up this the equations part, and I'm going to go up to bring up our first equation. I'm going to delete it. I'm going to write our second equation, so negative 2x plus 8. And we know this graph starts at 2, so let's go menu, trace, graph trace, and to enter. It takes us there, 2 and 4. So that's actually the same point as our first graph. So we can share this point, but now for this part of the graph, the value where x is 2 is now included. So we actually now fill in this circle. Now it's become a closed circle. And this part of the graph, this part of the graph ends at 7. So we need to find that point. So 7 and enter on the CAS. This point 7, negative 6. So we need to go there. So 7 is here, negative 6 is here. So where they meet is right here. So we label it 7, negative 6. And we are not including 7. So this needs to be an open circle. And now we have 2 points. We connect these 2 points and this is our graph. So see how this is different to a normal linear graph where we just have one straight line. This has 2 parts like this. The blue part starts here, ends here. The yellow part, the second part, starts here and ends here. Alright, now let's give this a little bit of context. So imagine we're buying some amount of sand. So we're probably building something, so we're buying some sand. Imagine this is sand. It's measured in cubic meters. That's a pretty standard measurement of 3D sort of volume. And the cost, how much it cost in dollars, it's given to us by these equations. Now, why are there 2 equations to show that the cost of sand? And it's, if we look at the domain here, the first part of the equation where it looks like we are paying $20 no matter how much we order, and every time we order a cubic centimeter of sand, we're multiplying that by 30. So every cubic meter we're adding is going to charge us extra $30. But this is only happening between when we're ordering from 0 to 4 cubic meters of sand. Because what happens as we order more, so anything between 4 to 10 cubic meters of sand, we have to pay $60 up front, but then every cubic meters of sand that we order is just going to be charged at $20. This is a little bit cheaper as you order more. So let's find out how much it's going to cost us if we order this much. When we order 3.5, we won't be looking at the second equation at all because 3.5 is within this domain. So we should be using this first equation. So all we need to do, we know the cost is going to be $20 no matter what, plus 30 times how much we're ordering. So we're ordering 3.5 much. So that's going to be, if I'm doing this right in my head, 105. So $125 altogether. Now, if we order 4 meters, now be careful where 4 meters is. 4's here, 4's here. But 4 is only included in the second part of the equation. It's not included here. It actually stops just before 4. So we need to be using this one. So here we've got cost equaling $60 no matter how much we order, times 20, and times how much we're actually ordering. So that's going to be 60 plus 80. So it's going to be $140 altogether. If we're ordering 8 cubic meters, 8 is part of this domain, so we should be using the second equation. So 60 plus 20 times how much we're ordering, which is 8. So it's going to be 60 plus 160. So altogether, it's going to be $220. So hopefully you can see why sometimes we need multiple equations to represent one scenario. And now we can graph this as well. To graph it again, we just want to put this into the CAS. And so again, for the first part of the equation, we want to do 20 plus 30x. And it's only between 0 to 4. So if we go trace, graph trace, 0, enter, it starts at 0, 20. So that's our first point. I should have made this scale a lot better. Let's rescale this and let's add another 0 here. Add another 0 here. So it's 150. $100, $50, negative $50, negative $100. So it starts at 0, 20. So it's right here. And this is going to be a closed circle because we're including this point. And so we should label it 0, 20. And then we're going all the way to 4. So 4 and enter. It's 4 and 140. So somewhere very high up here, we need much better scales here. So let's rescale all of this because we're going to go a lot higher. Especially like see, we have to go at least 200. So if we just relabel all of this to, let's just do 200 and 100 here. So then every little scale is 20. So this is our new point, 0, 20. And then we got 1, 2, 3, 4 and 140 right here. So we got 4, 140. And we're not actually including this point. So this is our graph for the first part. And for the second part, if you go tab, go up, I would delete this. Replace it with 60 plus 20x. And it starts at 4 and including that point. So 140, so it's actually the same point, but now it's being included. So we fill it in, make it a closed circle, and it goes all the way to 10. So type 10 and enter. That's 260. 10, 260. So it's going to be roughly around here. Draw a graph like that. Label this point 10, 260. And that's our piecewise graph for this scenario. All right, very last thing we're learning today is a step graph. So a step graph happens when we have a bunch of linear graphs that are flat. So looking at this scenario here, we're investing this much money. It makes 12% as interest, which is compounding every year. And in this table, we can see what's happening. So we'll start with this value at 0. And all the way until we reach 1 year, we're not making any money. So it stays at this value. But then after 1 year, we're making that 12% interest. And we're staying at this value all the way till we're at 2 years. So just looking at these two, let's put money here and like number of years, so time here. So between when the time is 0 to 1, so between 0, when time is 0, to when time is 1, we are, the amount of money we have doesn't change. It's a flat $10,000. Let's put a little break here because we might be skipping a fair bit here. $10,000. So it's a straight graph. But just note that we're not including this 1 year because at this point we haven't reached 1 year, because as soon as we reach 1 year, we're making that interest. So to show that we're not actually including this 1 year, we'll make it an open circle. Now, from 1 year all the way to 2 years, because now we made that little bit of interest, whereas our bank account, the balance in our bank account is this 11,200. So the scaling's a little bit off, but let's put 11,200 here. So from 2 years, so at the end of 1 year, starting of 1 year, all the way till 2 years, not including that 2 years, our bank balance is this. And 2 to 3, our bank balance is 12544 because we made a bit of a 544, bit more interest. So it goes like that, and see how all the little linear graphs that we have 3 so far. They make like steps, so we call these step graphs. So make sure you fill in the rest, the 4 and 5, all the way till 5, and see how it steps out.